At the moment, we're on our way from the spring point to the solstice, the beginning of summer. We'll be there in 12 weeks. Each year, the Earth, Sun, and Saturn have their conjunction. Sometimes Venus joins them. It all takes place behind the Sun, invisibly, but you can see it here on your screen. 3 months ago, we saw Venus in the morning to the right of the Sun. In 3 months, Venus, close to the Sun and faster than us on its orbit, will have covered all this distance and will slip behind the Sun. At the start of the year, the Earth was here. We saw Saturn in the evening to the left of the Sun. Over the last 3 months, Saturn has hardly moved. Meanwhile, we've covered a quarter of our orbit, and now we can't see Saturn lined up behind the Sun. It crosses the sky, hidden by the Sun. This is how the dance of the planets has brought us a triple conjunction. Venus has overtaken us. Saturn has barely moved, but the Earth has traveled on, so we all find ourselves in line. Saturn, Venus, the Sun, and Earth. The Sun's light only takes 8 minutes to reach us. The Sun and the planets are very close. This is our backyard. The stars are quite another story. Let's take Orion, one of the great constellations, visible despite the city lights which conceal most stars. Orion is composed of 8 major stars. And now imagine looking at Orion, not from the Earth, but from another part of the universe. There we see the 8 stars are at very different distances. The light that reaches us today from these stars left them in different centuries, showing us stars as they were in our grandfather's day, others as they were in the age of Charlemagne. Images from different centuries superimposed form our view of Orion. Looking at stars and galaxies, we travel back in time. But we see our solar system in real time, live. At the end of March 1997, the Hale-Bopp comet overflew the Sun and Earth. It may have already passed close by 3,000 years ago, or it might be a new comet visiting us for the first time. It's difficult to say how bright comets will be. Comets are less reliable than our neighbors, the planets. We know exactly where the planets are today and where they'll be in the future. The planets circle on elliptical orbits, almost circles. Comets go around the Sun too, but on eccentric orbits in the form of elongated ellipses. Comets are chunks of ice and dust, huge, dirty snowballs. When they approach the Sun, they warm up and throw off enormous amounts of gas and dust. Lit by the Sun, this lost material forms the comet's tail, which stretches out in the sky, always away from the Sun. It's difficult to say how much gas the comet will throw off, and so it's hard to say how visible it will be. The Hale-Bopp comet passed near the Sun, and it will travel so far away that it will take 3,000 years to come back again. We think that comets formed at the same time as the Earth and the planets, 4.5 billion years ago in the region where Saturn and Uranus orbit. They're chunks of ice and dust which didn't stick to any of the planets, or Saturn's rings, for example. The giant planets, Jupiter and Saturn, caused a lot of disturbance, and these dirty snowballs were thrown out to the limits of the solar system towards the distant ball called Oort's cloud, which contains billions of comet cores. Here, we're so far from the sun that its pull is almost non-existent. But a weak impulsion can propel one of these balls back into the solar system. After a journey lasting several millennia, here's a new comet flaring up as it passes the sun. Over the next thousands of years, it will return to the outskirts of the solar system. But sometimes a comet is captured by a giant planet like Jupiter. And that is the end of the comet. One comet is an old acquaintance, Halley's Comet. It passes close by the Sun and the Earth every 76 years, then moves off past the orbit of Neptune. As we watch its passages, we see history in fast forward. 3 centuries before Christ, it's observed by Chinese astronomers. In the 11th century, it glows over William the Conqueror as he sets sail for England. In the 14th century, it inspires the painter Giotto. The comet was seen at each passage, but nobody realized it was the same one. In the 17th century, the astronomer Edmund Halley calculated its next appearance in 76 years. Too late for him. But when the comet reappeared, his students remembered his prediction and gave it Halley's name. Since then, the comet has returned only 4 times. That gives us an idea of the size of our solar system. The 76 years that Halley's Comet takes to travel around its orbit matches our average lifespan. The youngest among you will see Halley's Comet return in 2062. Other comets pass by more closely. Some even cross the Earth's orbit.